Today, as of recording this, it's March 13th, 2026. I'm Cole Bucket, and this is my second entry documenting my progress in learning cybersecurity. In my last video, I was mostly learning basic terms and definitions like IP addresses, MAC addresses, DNS, and things like that. Today was pretty similar, but I also did a couple of new things, which is pretty exciting. Firstly, today I set up a virtual machine, as you'll see in the background here. I installed Kali Linux on it. I'm not sure how much I'm going to be using that, but I figured it'd be good to go ahead and get it installed early and maybe start trying to get a little familiar with it. A majority of the session was spent trying to learn the OSI model. I probably spent maybe the better half of an hour on that. I've been trying to wrap my head around how the different layers work together and how data flows through them. And I went over topologies too. So I tried a small pen testing minigame. I'm not sure. That was probably in the middle. I honestly had no idea what I was doing. That definitely showed me how much I have to learn. So there's that. And I guess I just noticed that I don't really have actually, you know what, I'm gonna get back on that. Right now I'm just gonna quiz myself. So on the topologies, let's see. So we have the star, let me put my notes down. We have the star topology. This is so we have a switch, and this all the different devices send their data to that switch, and that switch can then send that data out to the internet, or send data to different devices. And this topology is a bit more costly but more common. If one device breaks or one cable breaks, then it doesn't destroy the entire network, pretty much. Data can still be sent out until that device is fixed. It's more costly because it requires more cabling, but you won't really see this, and you won't really see switches in households. Well, I guess you will, but you won't really see like huge ones in households, I should say. Okay, and then let me fact check that. Oh wait, that's ring topology. Wait, we're starting with topology. Here. Yeah. This is commonly found today because of its reliability and scalability despite the cost. So it gets a bit more expensive. Okay, next we have the bus topology. This topology, you have one, let's see. This one's a bit hard. I can't really remember it. So you have these devices, and all the data is being sent through one like mega cable. And while this is more cost effective, once you start sending lots of data at once, it can begin to bootleg and stop the network entirely, because there's just too much data overflow in that one cable. And I think that's about it. Let me see. Oh, actually, I guess not. Okay, let's see. Relies upon a single connection. All data destined for each device travels along the same cable, so it is very quickly prone to becoming slow and bottlenecked. Oh, did I say bootlegged? Bottlenecked, I meant. Devices within the technology are simultaneously requesting data. This bottleneck also results in very difficult troubleshooting because it quickly becomes difficult to identify which device is experiencing issues with data traveling along the same route. Okay. Next, we got the ring topology. So put my notes down. So this is just data is traveling in one big ring connected by different devices. So computer 1 can send data through a cable to computer 2, and then computer 2 will send data to computer 3 through a cable or whatever. Then 3 to 4, 4 to 5, 5 back to 1. so on and so forth. The thing with this is that you can't. It doesn't seem optimized, because if you need, it can either only go clockwise or counterclockwise. Data cannot. You can't send data from computer 1 straight to computer 3. You have to go through computer 2 first. And I can see an issue in that already. If one computer is compromised, say computer 3 is compromised, but you have to send data from computer 2 to computer 5, you have to go through that compromised computer. And I guess you can lose data there, have data stolen or whatever. And if one device is out of commission, the entire network is out of commission. One thing I don't get about it though is if you have one cable cut between like computer 4 and 5, can you still send data from computer 1 up to computer 4, I guess? I don't know. Or vice versa, can you send data from 4 to whatever? Okay, let's check my notes. Devices, oh yeah, and this is more cost effective, I'm pretty sure. Devices such as computers are connected directly to each other to form a loop, meaning that there is little cabling required and less dependence on dedicated hardware, such as within a star topology. Okay, then we have a loop. Fundamental programming concept. It is a sequence of instructions or code that executes repeatedly, until a specific condition is met or an action is triggered. And let's see, now I have the network topology. Router connects networks and passes data between them, done by routing. Routing, the label given to the process of data. Okay, switch. So a switch is just like a big old hub. You're gonna have lots of cables running from this to different devices. You're gonna see bigger, more scaling ones in bigger companies. With a switch, do I need to hit on something? Okay, yeah. So, okay. With a switch, you can also subnet too to help break up kind of the workload, I guess, for the switch and for data and devices. Let's see. I think the next one said packets. Okay. Damn, wait. I'm not looking at my notes. I'm trying to remember. Packets. So you're going to have, this is where its data is broken up into smaller chunks, I think. Let me go ahead and fact check that actually. Yes, okay, yeah. Pieces of data broken down into smaller and more manageable pieces can later be reassembled in... Yep. I'll get into that in the OSI model. I definitely know it. Okay, so subnetting. Splitting up a network into smaller miniature networks within itself. Yeah. Subnets use IP addresses in 3 ways. Identify the network address, identify the host address, identify the default gateway. Okay, oh yikes, okay. I was pretty confused on this one actually. I didn't really get it. I can't even quiz myself on it. Network address. This address identifies the start of the actual network and is used to identify a network's existence. I don't get it. I don't know. Maybe I'm an idiot. Maybe I just wrote this down wrong, or it's just not computing in my brain or something. Host address, an IP address here is used to identify a device on the subnet. Okay, I get that one. Okay, default gateway. A special address assigned to a device on the network that is capable of sending information to another. Okay, yeah, I get that one. Sorry. I'm not cutting that out. I'm lazy as hell. Or address resolution protocol. Okay, is responsible for finding the MAC address. Okay, wait, hold on. I know this one. I'm pretty sure I know this one. So this is going to be, you have the ARP request and the ARP reply. The ARP is going to be asking a device for its MAC address, and I think it might ask for its IP address too. It's going to send that out there. It's going to be like, hey, who has this MAC address? And then the reply is the device replying back saying that that is my MAC address. And then let me actually not say that. So, okay, yeah. Okay, DHCP Dynamic Host Configuration Protocol. Okay, this is going to be where a device gets on a network, and if it doesn't have an IP address manually entered, it's going to ask the DHCP for an automatic IP address. And so let's see, this is going to be DHCP, I want to say request from the device to the DHCP. Then, okay, so the device will ask, I'm on the network, can I have an IP address? And then, let's see, I want to say DHCP replies, gives it an IP address. So maybe it goes from DHCP request, then to reply, and then the device says, okay, I'll use blank IP address. Damn it, I don't know after this. Okay, here. DHCP discover, DHCP offer, DHCP request, DHCP act. Sorry, I misinformed. A network management protocol used on IPN network for automatically assigning IP addresses and other communicating parameters to devices connected to the network using a client-server architecture. Oh, here we go. This is what I did today. OSI, Open Systems Information Model. Okay, so this is how data flows. This is a 7-layer architecture on how data flows through a computer, I'm going to say. So let's see if I can remember this off the top of my head. And I'm just going to say number 1. Number 1 is physical. So this is the easiest. This is just going to be your hardware. Cable, computer, stuff like that. Then number 2, data link. So I think this is going to be the connection, but no. Okay, I'm going to have to look at my notes before I just start lying. Oh yeah, and back to physical. Devices use electrical signals to transfer data between each other in a binary numbering system, ones and O's. So you knew that though. Physical addressing at transmission. It receives a packet from the network layer, including the IP for the computer, and adds in the physical MAC address at the receiving endpoint. Inside every network-enabled computer is an NCI network interface card. Yes, which comes with a unique MAC address to identify it. It's the job of the data link layer to present data in a format suitable for transmission. MAC addresses. Let's see if I can. Okay, MAC addresses are the addresses burnt into like a computer's hardware chip. Though they cannot be changed on the computer, they can be spoofed. And when I say changed on the computer, I meant like changed physically, I think. Well, obviously, I'm sure you could change the MAC address if you just swap out the parts, but I don't think you can change a MAC address already burnt into the computer unless you spoof it. IP addresses, those can be changed. Those are very suited. Oh, hold on. I can't even think of the word. Those can change that easily. 3, we have network. Let's see. The third layer of the OSI model is where let's see, we have routing and reassembly of data. So breaking down that packets and reassembling those packets. Let's see, routing determines the most optimal path. That's what I was talking about with like the ring topology. It can't take really optimal paths. It just has to go around in a circle. In which chunks of data should be sent to the most optimal path. While some protocols use this layer determines exactly what the most optimal path that data should be sent to another device. These protocols include OSPF, Open Shortest Path First, and RIP, Routing Information Protocol. These factors decide which route is took, which path is the shortest. What path is the most okay, so which path is the shortest? How can we get this data to the device it needs to be sent to in the shortest path possible? I don't know how else to really explain it beyond that. What path is the most reliable? So has a path ever lost packets before? If so, send it on a more reliable route. Which path has the fastest physical connection? So this isn't how short that is, but how fast can data be sent through that path? Okay. Then 4, we have transport. Layer 4, the OSI model plays a vital part in transmitting data across a network and can be a little difficult to grasp. When data is sent between devices, it follows one of two different protocols. Okay, TCP and UDP. Transmission Control Protocol. Let me see if I can get this without looking at my notes. So this is going to be where it needs a three-way device handshake, and it needs every packet sent. If it doesn't get one packet, all the data from that is voided. And so this requires, let's see, I'm going to say this requires a connection whilst it's active. Whilst data is being sent, it requires a connection. It's pretty reliable and safe, but that being said, it can be slower because it needs, let's see, why is it slower? I guess because it needs to just fact check that all the data is there, which is why it's slower. And then, like I said, that if you don't get one small piece of data, then all the data is voided. Then you have UDP, User Datagram Protocol. So this is going to be, it doesn't require a connection at all. It's just going to send data every which way it can. It doesn't care if it gets all the data or not. So you can end up with data lost. So for TCP, this is going to be for like downloading stuff off the internet and I guess like movies and stuff. UDP is going to be for like live streaming because it's faster, but you can lose that data, which I guess is what packet loss comes from, now that I think about it. Let's see, advantages of TCP. Guarantees the accuracy of data, capable of synchronizing two devices to prevent each other from flooded with data. From being flooded with data, okay. Performs much more processes for reliability. Okay. Disadvantages of TCP. If one small chunk is lost, the entire chunk of data can't be used. TCP is slower than UDP. Alright, then number 5, we have session. Okay, I think I can hit on this one a little bit without looking at my notes. So session is going to be a connection that when a connection is made between two devices, a session is made between those two devices. So whilst the connection is active, the session is active, and once the connection is not used for a while or is closed or whatever, that session also goes away. Let's see right now. Once data has been correctly translated or formatted from the presentation layer 6, the session layer will begin to create and maintain the connection in order to other computers for which the data is destined. When a connection is established, a session is created whilst the connection is active. So is the session. The session layer is also responsible for closing the connection if it hasn't been used in a while or if it is lost. Additionally, a session can contain checkpoints where if the data is lost, only newest pieces of data are required to be sent. Sorry, that was my Coke. Saving bandwidth. Sessions are unique, meaning data can't travel over different sessions, but only across. Okay. I get that, but I don't get it. Like, I can see it in my head, but... 6. Presentation. Okay. I think I got this one down pretty well. So, this is where I'm doing that pen testing minigame. I suck so bad at that. I had no clue what I was doing, but okay. What was I talking about? Oh yeah, presentation. So this is gonna be like where it's formatting the data to become readable. Like it's a translator pretty much. Say you're using one email client, but another person that you're emailing is using another email client. You're still receiving that data, the email they sent you, and you're still seeing that data, even though it might come up with data differently. This presentation layer is translating that data into just like a formatted language, I guess. I think security checkpoints also take place here too. Let's see, what else? I'm just going to read from my notes now. Let's see. Layer 6 of the OSI model is the layer in which standardization starts to take place. Because software developers can develop any software, such as an email, differently, the data still needs to be handled the same. This layer acts as a translator for data to and from the application layer, layer 7. The receiving computer will also understand data sent to a computer in one format destined for in another format. For example, when you send an email, the other user may use a different email client, but the data still displays the same. Security features, yes, such as data encryption, like HTTPS when visiting a server site. Secure site, sorry, not server site. Occurs at this layer. So finally we have application. This is what we are going to be most familiar with. I'm seeing application all over my screen right now. I'm seeing this recording voiceover GUI. I'm seeing this DaVinci GUI. I'm seeing my Obsidian GUI. Tap on my phone. I see that GUI. Is that a GUI? I'm going to think it is. I'm seeing application everywhere on my computer, and so are you if anybody is watching this. This is just going to be how data is presented on your computer screen, pretty much. Okay, now let's see. 7. Application. The application layer of the OSI model is the one that you'll be most familiar with. Yes. This familiarity is because the application layer is the layer in which protocols and rules are in place to determine how the user should interact with data sent or received. Everyday applications such as email clients, browsers, or file-serving browsing software such as FileZilla provide a friendly GUI, graphical user interface, for users to interact with data sent or received. Other protocols include DNS, domain name system, which is how website addresses are translated into IP addresses. Okay, and that's what I did. Let's see how much time I have. Oh, I still have a lot of time left. I feel like I had to hit back on something. Let's see. But yeah, there's a lot of footage from this one. I spent a lot of time on it because I like to write down everything. So there will be no Cooking Fever gameplay, sadly. I know. I'm so sad. And my 100 million ghost viewers are also super sad. Let's see, I had to hit back on something up here. Oh, right. So, I think I might have talked about this yesterday too. But I just don't think I have the... I don't think, I know. I know I don't have the passion for healthcare as I do for this. Studying, like, for me has always been a little difficult because, and that's partly because I never really had to study for high school, or I don't have to study for high school. I can just go there and I can hear what we're talking about. I'm gonna make pretty good grades, but I know it doesn't work that way in college. But learning and studying and stuff like that has always just felt kind of like a chore to me. This doesn't feel like a chore. I really enjoy learning this, actually. Is that bound to change? I don't know. It could be. It could be bound to change, yeah. But as of right now, I'm really enjoying this, so... yeah. Being in healthcare is cool, but you gotta put up with crappy pay unless you commit yourself to a college, and medical school is expensive. Going to college for however long you need to be in a CNA, not CNA, nurse practitioner is expensive. Certified nurse of anesthesia, or whatever it's called, takes a long time too. Lots of people want to get into healthcare because they just want to make $1, and I feel like it's kind of flip-flop with cyber. I can see it, like the job markets are kind of flip-flop because nobody wants to do healthcare, so the job market, they'll just hire pretty much anybody, and by anybody I mean they'll hire people who don't even have the passion for it. I don't think they should be subjecting their patients to that. Nurses shouldn't, because they just want to make a buck. Getting your RN is easy, probably one of the easiest things anybody could do. They don't know nothing, they don't teach you nothing. That's a joke. Obviously, I'm very grateful to all nurses and stuff, but seriously, nurses these days suck, and it's because they are so desperate. The hospitals are so desperate to hire anybody. They're so understaffed. So they'll just hire. Yeah, I don't need to say it 3 times. I've made my point clear. And that being said, there are really good nurses. I've had great nurses pretty much my whole life. I've only had a few bad nurses. But yeah, so you can get a job pretty much anywhere in healthcare, so long as you go through the education for it. Yeah. It's not really that way with cybersecurity. They say there's so many unfilled jobs, but I don't think that's true. I think lots of the seats are already filled. It's so oversaturated, and what's gonna happen with AI and this, I don't know. But I believe, yeah, you know what, yeah, I believe God has a plan for me, and I'm gonna see it through. I'm gonna place my blind faith into Him and just pray that everything works out. And if it doesn't, well, then we'll see what happens. Ooh, I need a water break. I think that's about it. I doubt anybody was listening to me ramble for 30 minutes, but if you were, and you have any tips, feedback, questions for me not involving cybersecurity, or, I mean, in that sense, I can't really answer stuff, like I can't really answer stuff about this yet, but if you have questions about like what I want to do in it, I doubt nobody is going to ask me that. I doubt this will get many views, but can you do? It's okay. I'm not really making this for anybody else besides myself. I feel like that's about it, though. So, peace. Deuces. Peace and love. God bless.